Let's add some decimals. What is wrong with 24.670, to which we add 913.58? We add the 8, we get 12, we get 0, 6, 1, 1. Well, we just added apples to oranges. For example, we added 9 hundredths to 2 tenths. What we should have done is line up the decimal point. That guarantees that we add 100 to 100, 10 to 10, 1 to 1, tenths to tenths, hundredths to hundredths. So when you add this, add as if you did not have a decimal point, and just reproduce a decimal point in the same vertical position. So what is new in adding decimal numbers? Nothing beyond putting in the decimal point and ensuring that the decimal points line up. The same applies to subtraction. Make sure the decimal point lines up and subtract like you're used to. Multiplication of decimals. 123 times 51 is 6,273. A quick check, 120 times 50, 120 times 50 is 6,000. 6,273. 12.3 times 51. 12 times 50 is 600. My result is 600 something. The decimal point belongs here. 1.23 times 51. 1.2 times 50 is about 60. The decimal point belongs here. To multiply two factors with decimals, carry out the multiplication as if there was no decimal point. Then count the number of digits in each factor. The decimal point is moved to the left by that number of digits. 6.7 times 10 to the 4 multiplied by 5.1 times 10 to the 3. First multiply 6.7 by 5.1, which gives you 34.17 times 10 to the 7. But in scientific notation, you need a number between 1 and 10. So write the 34.17 as 3.417 times 10. And then you combine the two tens. 10 times 10 to the 7 is 10 to the 8. So scientific notation, there should be only one equal sign here. 3.417 times 10 to the 8. Example 2. Find the quotient of 3.2 times 10 to the 7 and 6.4 times 10 to the 3. Quotient means division. When we divide 3.2 by 6.4, we get 0.5. Subtract the 3 from the 7, that's 10 to the 4. Now borrow one of the tens here. You have 4 tens, you're left with 3. Associate with a 0.5. 0.5 times 10 is 5, a number between 1 and 10 times 10 to the 3rd power. Find the product of 6.7, 10 to the 4, and 5.1 times 10 to the 3rd, and give your result in scientific notation. So again, multiply 6.7 by 5.1, you get 34.13. And 10 to the 4 times 10 to the 3 is 10 to the 7. Rewrite the 34.17 as 3.417 times 10. And multiply that 10 by the 10 to the 7 to give you 10 to the 8. Okay. Multiplication by 10 is equivalent to moving the decimal point one place to the right. Like 5 times 10 gives you 50. Multiplying by 10 makes the number bigger. Division by 10 is equivalent to moving the decimal point one place to the left. 50 over 10 is 5. When you divide by 10, the number gets smaller. If there is a decimal, is there a decimal point in the whole number 2? Yes, there is. Because that is in the ones place, you can put a decimal point right after the 2, and you can indicate a 0 here. There are no tens here, and there are 0 tenths here, so that's the same thing. Now, 2 times 10 is 2.0 times 10. and multiplication is repeated addition, so you get 2.0 plus 2.0 plus 2.0. 10 of these are added up, which gives you 20. Notice that the decimal point moved one place to the right. That's because we have using the decimal point where we collect groups of tens. Convert numbers from scientific or exponential notation to standard or decimal notation. Well, this is 10 to the 5. We multiply it by 10 times 10 times 10 times 10 times 10. So 5 tens, which means the decimal point goes 5 places to the right. It was here, 1, 2, 3, 4, 5. And 3.17 divided by 10 to the 5. You divide by 5 tens, and you move the decimal point from here 1, 2, 3, 4, 5 places to the left. The number gets smaller.